Hey everyone, today we're looking at Unit 2, Lesson 3, applying slope, midpoint, and length formula. So we're going to continue working with our midpoint formula and our length or distance formula to solve some different analytic geometry word problems. So the first one we're going to look at today says a right angle triangle has vertices at A, which is 3, 4, point B at 6, -2, and point C, which is at point 1, 3. Which vertex corner contains 90-degree angle? So we are going to want to try to solve this algebraically. So I'm just going to write here, solve algebraically, not graphically. Okay, we could maybe get some graph paper out and try to look at what this is on a graph. But we have to know something about that 90-degree angle, and you might have seen this in grade 9 as well. But when we're talking about the slope of something and two lines meeting together at a 90-degree angle, their slopes are going to be negative reciprocals of each other. So let's just make a note of that to remember from grade 9. So two lines that meet at a right angle which is 90 degrees, have slopes that are negative reciprocals. And let's just put an example here so we can remember what negative reciprocals are. So i.e., one line could have a slope of -1/3, and then a line that meets at a right or a 90-degree angle to that line could have a slope of a +3/1, okay? So if one line has a slope of a -1/3, the line that has a perpendicular to that line is going to have a slope that's flipped and with a different sign, so 3/1. So for this question, we're going to need to calculate the slopes of each line. Of each line segment to look for negative reciprocals. All right, so we will start with the slope of line segment AB. So remember, our slope is the change in y over the change in x. So the y values for AB are going to be a -2 minus a +4 and 6 minus 3. So that's going to equal a -6/3, which is going to equal a -2/1. Okay, we'll take a look at what is our slope of BC. So our y values for B and C are going to be 3 minus a -2, and our x values are 1 minus 6. So 3 minus a -2 is going to be a 3 plus 2, which is 5, and 1 minus 6 is a -5. So that's going to simplify to just -1. And then our last slope we're going to need to calculate is from C to A. So from C to A, my y values are 4 minus 3 and 3 minus 1 for my x values. So we're going to have 4 minus 3 is 1/2. All right. So hopefully we can see, if we look across our slopes here, are any of them negative reciprocals of each other? Right. Well, I have a slope here that's -2/1 and a slope here that's 1/2. So it's flipped and it has a different sign on it, right? It goes from -2/1 to a +1/2. So we can say, since the slopes of AB and CA are negative reciprocals, therefore vertex A, so the corner of A, if we were thinking about the triangle, is the 90-degree angle. Okay? So we're able to apply the slope formula to help us determine if there was a right angle in that triangle without graphing it, without drawing it, just by using what we know about slope and algebra to figure that out. So let's take a look at this next question. So determine the equation for the line that crosses through the midpoint between point E and F and is perpendicular to the line y equals 4x minus 2. So a couple keywords there that we should point out that we're going to have to use here. So we're going to be looking at the midpoint of a couple points. We're also going to be looking for something that is perpendicular. So remember, if it's perpendicular, we're going to have negative reciprocal slopes. Okay, so whenever we're trying to find the equation of the line, because it's asking us to determine the equation for a line, we need two pieces of information. So we need only two pieces of information to determine equation of a line. Okay, so that could be slope, which remember is represented by m, could be our y-intercept, which is represented by b, or a point, okay, which we would represent as x and y in the equation of the line. So based on the information they've given us there, can we find any of those two pieces of information? And if we've been given 2 points, we can determine a slope and a point on the line. So we can determine the slope and a point we have been given on the line. So we were told that the slope is perpendicular to this line, okay? So my slope of my original line here is 4. So if we need to find the slope of the line we're trying to come up with an equation with, it's going to be the negative reciprocal of that. So I'm going to take 4, I'm going to flip it, so it's going to become 1 over 4, and I'm going to change the sign. So we're going to have m is equal to 1/4. So that's because this is the negative reciprocal of our slope from y equals 4x minus 2. So that 4 is the slope in that equation, and we needed a slope that is perpendicular to it, so it's the negative reciprocal of it. Okay, we can also figure out a point on this line because it says that the midpoint, so if we were trying to figure out a point xy, right, we know that the midpoint of EF lies on this line as well. So let's see if we can find the midpoint of EF. So the midpoint of EF is going to be equal to the average of E and F. So the x values, let's just write x1 plus x2 divided by 2, and then y1 plus y2 divided by 2, just to remember what our midpoint formula is. So our x values from point E and point F, if we look back up in our problem, our x values, right, were 4 and 8. So 4 plus 8 divided by 2. And our y values were a negative 3 plus 13 divided by 2. So we'll continue to simplify this. We'll have 12 over 2 and 10 over 2. So we can say that the midpoint of EF is 6, 5, right? Now we have a point on the line. So we're going to use our slope and we're going to use a point on the line to come up with our equation. So let's just label this. We first got our slope. Next, we determined a point on the line. Okay, I'm going to write a number 3 over here and draw an arrow. Now, we need to find our y-intercept, which is b. So we're going to sub in our slope, which was a -1/4, and the point we found, which was 6, 5. Okay, so in for y equals mx plus b, we're going to have 5 in for my y, -1/4 in for slope, and 6 in for our x. Okay, so a -1/4 times 6 is going to be a -6/4 plus b. I'm going to bring that 6/4 over to the other side by adding it. I'm also going to reduce it, so that would reduce to 3/2. So I'm moving it by addition, but I'm reducing it as well. And then if we were to get a common denominator, so we could add these two fractions together, it would be 10/2 plus 3/2 equals b. So 13/2 equals b. Running out of room here. Okay, so we have our slope. We have our y-intercept. We can finally write our equation. So we're going to have y equals -1/4 x plus 13/2. Okay, and that's going to be our equation. That is our final answer. Lots of work there, right? But we were able to kind of apply what we know about slope in terms of perpendicular lines. We were able to apply our midpoint formula to come up with the equation for this new line. Now, let's try one more example. Okay, so determine the shortest distance from point C to the line passing through the points D and E. So I'm going to do a rough sketch of this, but we are still going to do this algebraically. So if we were to draw a rough sketch of what is being told to us here. Okay, it says point D is at -2, -3, so we'll say somewhere here. It says point E is at 7 and 15, so let's say that's somewhere there. Okay, and that makes a line, so let's get our calculator out, let's get our ruler out, and we'll just draw a nice straight line to connect those dots, even though this is a rough sketch. Okay, and I'm going to label my point. So this was point D, and it was at -2, -3. And this was point E, which is at 7, 15. All right, it says point C is somewhere over here, so -4 and 8. Let's say somewhere here. And it says determine the shortest distance from the point C to that line. So what's the shortest distance from here to this line? Okay, well the shortest distance, let's just make a note. The shortest distance is going to make, or actually not say let's make, the shortest distance would be a line that's perpendicular, and I'm just going to write the math symbol for perpendicular. It looks like an upside down T because it's like a right angle. A line that's perpendicular to line segment DE. All right, so the shortest distance is going to be a line that is going to end up being perpendicular, so it's going to make a right angle with DE. So if we know this to be true, we can first start by finding our slope. So we're going to find the slope of DE, and then ultimately we'll be able to find the slope of C, and let's call this point that it meets at B. Let's just say that it's going to meet at point B, okay? So we'll find the slope of DE and CB. We know that line segment CB is going to be perpendicular, remember that means perpendicular, to DE. So slopes are negative reciprocals. Okay, so first let's just find the slope of DE because we have 2 points, so we should be able to do that. So slope of DE is going to be my change in y. So my y values are 15 minus a negative 3 over the change in my x values, which is 7 minus a negative 2. So DE is going to be 15 minus a negative is going to be plus. So we're going to have 18. And then 7 minus a minus is again a plus. So we're going to have over 9. So the slope of DE is going to reduce to just a positive 2 over 1, let's say. Okay, so if the slope of DE is 2 over 1, then we should be able to see that the slope of CB is going to be a negative reciprocal. Of DE, so our slope is going to be, I'm going to take 2 over 1, I'm going to flip it, and I'm going to change the sign. So my slope of CB is going to be a negative 1/2. So we need to now find the equation, or we have to start working to find the equation that's going to kind of satisfy what we're saying here. So we don't know exactly where it's going to cross DE, but hopefully we can see it doesn't look like it's the midpoint. It actually looks like it's going to be closer to point D than to point E. So let's try to find the B value for both of these. Let's try to find our y-intercept for DE and our y-intercept for CB. And then maybe we can figure out where do these lines intersect. So step 2 here, I'm going to find our B value for DE. Okay. So I'm going to sub in what information I have. I'm going to sub in that M is equal to 2. And I can take any point on that line. So let's just take point E, which is 7, 15. All right, so into y equals mx plus b, I'm going to start subbing things in. So my y value is 15, my slope is 2, and my x is 7. So we'll simplify where we can. I'm going to move 14 over by subtracting it. So we're going to have 1 is equal to b. Okay, so we have our slope, and we have our y-intercept. So we can write the equation for this line as y equals 2x. Let's just circle, there's my slope. There's my y-intercept. So y equals 2x plus 1. Okay, that's my equation for DE. Let's see if we can kind of repeat that process and find our B value for CB, right? So again, we need to know our slope. So we'll sub in our slope, which for CB is a negative 1/2. And the point we have is point C. We don't know the other point yet, right? So our point C is a negative 4, 8. So we're going to sub those into y equals mx plus b. So in for y, I'm subbing an 8. Okay, I'm going to substitute my slope of negative 1/2 in, my x of negative 4. So a negative 1/2 times a negative 4 is a positive 2. And then I'll move that 2 over to the other side by subtracting. So I'll get that my b value or my y-intercept is 6. I know my slope is negative 1/2. So I can write the equation of this line as y equals negative 1/2 x plus 6. Okay, so now I have these two equations. All right, they're going to intersect at some point, just like we saw in our unit on linear systems. So let's call this equation 1, equation 2, and we're going to treat this as a linear system that now we need to find their solution or their point of intersection. So we're going to find the point of intersection for the two lines. Okay, so let's sub equation 1 into equation 2. Okay, so instead of a y for my equation 2, I'm just going to have my brackets there. That's going to tell me I'm going to sub in whatever y equals. Okay, so my y equals from equation 1 is 2x plus 1. All right, I want to kind of deal with getting rid of that fraction. So I'm going to multiply this whole equation by 2, just so that I don't have a fraction to worry about. So if I multiply this whole equation by 2, both sides, right, I'm going to get 4x plus 2 equals 2 times a negative 1/2 is just going to be a negative 1x plus 12. Okay, I'm going to work to combine my like terms. So I'm going to add 1x to the left, and I'm going to subtract 2 to bring it over to the right. So we got 5x equals 10, and we'll divide both sides by 5, and we'll find that x is going to equal 2, okay? So that's going to be part of my point of intersection. So part of B, if I came back up here to my graph, I know x is going to be 2. Now I have to figure out what my y value is going to be. So we can sub that into either equation. Let's sub x equals 2 into the easier of the two equations is probably equation 1. So my equation 1 is y equals 2x, so 2 times 2 plus 1. And we'll just simplify on this side of the equation. So we should get that y is equal to 5. So we can write that 5 up here. Okay, so now we have 2 points on that line. Remember, the question was determine the shortest distance, right? So we have to find the shortest distance, which we said is going to be a line that's perpendicular to line DE. So now we actually have to find, okay, what is that distance? What is the length from C to B? So that's going to be the last step for us, is we're going to find the distance between C, which was negative 4, 8, and this point that we have now found through all this math, point B, which is 2, 5. So we're going to use our distance formula, which is going to be, remember, the difference in my x's squared plus the difference in my y's. So my x's are negative 4 minus 2 squared plus the change in my y values, 8 minus 5 squared. This is going to give us the length of line segment CB. I'm just going to change that to the length of CB. So we have a negative 4 minus 2, that's a negative 6 squared, plus 8 minus 5 is 3 squared. Okay, so we have 36 plus 9, running out of room. Okay, so we're going to have a square root of 45. Just going to take this over here. So if we were to take the square root of 45, you should get 6.7. So that tells us the length of that line. That also answers our question about the shortest distance. So we can say, therefore, the shortest distance is 6.7 units. We didn't have any units to measure on this, so we'll just say units. Whole lot of math and a bunch of consolidation of the things we've been learning in class so far. We were able to calculate slope, determine the equation of a line, find the point of intersection of two lines, and apply our distance formula. So a ton of math that we've been working on, all kind of consolidated into one question. That's it for your note for today.